Welcome everyone to our video on predicting precipitates in chemical reactions. In this video, we are going to look at how to use the KSP value to determine if a precipitate will form in an ionic reaction in solution. Recall that previously we used a set of solubility rules to determine whether a precipitate will form. Those rules are qualitative, as in they really just group chemicals together as either being soluble or insoluble with a specific cutoff. However, it's very possible that substances that are classified as soluble, if you dissolve enough of that ionic compound in water, you can get a precipitate. And conversely, it is possible that substances that are classified as insoluble, if you have a low enough concentration, they will dissolve. Our KSP value will allow us to look at a more nuanced view of precipitation. Our test to predict precipitation is going to be to compare the KSP value to the concentrations of the ions. Recall that KSP is equal to the product of the ions raised to their coefficients in the balanced chemical equation. Our test to determine whether a precipitate will form will be to compare the two sides of the KSP equation. If the product of those concentrations raised to their coefficients is greater than the KSP value, then the equilibrium system is going to shift left in order to reach equilibrium. Since the left side of this equation has a solid ionic compound, what's happening? A precipitate is forming. The ions are coming out of solution as the system shifts to the left. Conversely, if the ion product is less than the KSP value, the system can shift to the right. More solid can be dissolved for the solution to reach equilibrium. What we call the system, this is an unsaturated ionic solution because more solid can still be dissolved. And obviously, by definition, if the ion product is equal to the KSP value, the system is at equilibrium. Let's now take a look at an example here. In this example, we are going to be considering a double displacement reaction. So we have 100 milliliters of one solution, 100 milliliters of another solution. We're combining the solutions, and we're going to check to see whether a precipitate will form. So let's switch over to the whiteboard and go through the steps in solving this problem. Let's start off with some balanced chemical equations here. Now, there's two reactions involved. First, we have a double displacement reaction between these two ionic compounds. And second of all, we have an equilibrium system that is going to result from one of the products of that double displacement reaction. Let's start off with the double displacement reaction and then look at the equilibrium system. So here's my double displacement reaction. Sodium nitrate is a highly soluble salt. So its KSP value is going to be quite large. We're not even going to worry about that. What we're interested in here, and we can see that I've provided the KSP value for magnesium hydroxide, is we're questioning whether we will actually get a precipitate given these initial concentrations. So this is the substance we're interested in. So let's write out the equilibrium equation for magnesium hydroxide. So magnesium hydroxide can form an equilibrium system, and the KSP value is equal to the ion product, magnesium ions multiplied by the hydroxide ions squared. Our test here is to look at this ion product and compare it to our known KSP value and see whether it is smaller, larger, or the same. A precipitate will only form if this ion product, the right-hand side here of this equation, is larger than the KSP value. So that's going to be our test. To compare these values to our KSP, we first need to find the concentration of magnesium and hydroxide ions in solution. Let's go back to our double displacement reaction, because that is going to be how we determine the concentrations of our magnesium and hydroxide ions in our product. What I've done here is write out the initial concentrations and volumes of each individual solution. However, these are not necessarily the concentrations and volumes that we're going to need in our KSP equation, because the KSP equation involves the concentrations after the reaction occurs, concentrations on this side of the equation. So in this equilibrium system, the volume is going to change. The volume is doubling. To find my new concentrations of magnesium ions and hydroxide ions, I'm going to need to use the dilution equation. Recall that is equal to M1V1 is equal to M2V2. After I've mixed these two solutions, here are my new concentrations of magnesium ions and hydroxide ions in solution. One step I skipped here was making the jump from concentrations of the ionic compound to the concentrations of the ions. And that's just because I look at the formula and I see that in magnesium nitrate, for every one magnesium nitrate, there's one magnesium ion. And for every one sodium hydroxide, there's one hydroxide ion. So the concentrations of the solutions given in the question are also equal to the concentrations of those specific ions in this case. Now that I have the concentrations of my ions in the product, I'm going to check to see whether their ion product is greater than the KSP value. Recall that here's my KSP equation. Don't forget to raise the hydroxide ion concentration to the power of 2. And we're going to compare the left side and the right side of this equation. Now that I've calculated these values on the right-hand side, I compare it to my KSP value on the left-hand side, and I see that this ion product is greater than the KSP. And if that's the case, we predict that a precipitate will form.